Welcome to this discussion on triangles, which comes under the topic of geometry. You are all familiar with this shape triangle. What is a triangle? A triangle is a shape within a plane which is formed by joining three non-linear points. In this discussion, we shall look at some properties of triangle, how to find area and perimeter of the triangle, some important lines within the triangle, and some specific types of triangle like equilateral triangle and right angle triangle, and then look at a couple of problems where we apply the learning that we have in this discussion. Let us first look at the properties of triangle. How does a triangle come into picture? A triangle is formed by joining three non-linear points. What do you mean by non-linear points? Points which are not in a line, not collinear. If I join these 3 points, I get a triangle. If these 3 points are on the same line, then I will not have a triangle. If I join any 3 non-linear points, they will form a triangle, and they will fall on the same plane also. Now, when it comes to properties of triangle, there are a few of them. The angle between, the sum of the angles between the sides of this triangle, if you add up, you will get a total of 180 degrees. That is the first property, which is very important. We use it very often when you do the problem. The second property is the side opposite to the largest angle will be the largest side. Okay. If this angle is bigger than the other two, then this side will be bigger than the other sides. As I said, in a triangle, the sum of the interior angles will be 180. So if I call this triangle A, B, C, the sum of angle A, angle B, and angle C will be 180. Now what is this angle? This is the exterior angle of the triangle. Okay, that is the exterior angle of this point C. This angle will be 180 minus C. Why? Because the angle within a line is 180 degrees. So this plus this should be 180. This is C. So this angle is 180 minus C. What about these two, sum of A and B? That is also 180 minus C, because A plus B plus C will be 180. So I can say that this exterior angle will be equal to the sum of the opposite interior angles of the triangle. This is another property of any triangle. Now, based on the sides of triangles or angles of triangle, we can classify the triangles in different ways. If I look at from the angle viewpoint, a triangle where all the angles are less than 90 degrees is called an obtuse angle triangle. A triangle where one angle is 90 degrees is called a right angle triangle. If one angle is 90, there is no possibility of any other angle being equal to or more than 90, because the sum of the 3 angles should definitely be equal to 180. A triangle where an angle is bigger than 90 degrees is called an obtuse angle triangle. This is from the angle perspective. Now, if you look at from the sides, if a triangle is there where all the 3 sides are having different values, then it is called a scalene triangle. If I have 2 sides of the triangle same, then it is called an isosceles triangle. If all the 3 sides of the triangle are same, then it is called an equilateral triangle. These are some important aspects of triangle that you should keep in mind. Now let us see how you find the area of a triangle. The most common method that we use to find area of a triangle is the formula area equals half into base into height. Let us draw a triangle and see how this comes. Let us say I have a triangle like this. I want to find the area of this triangle. So what you can do is, you can draw a rectangle enclosing this triangle inside. If you cut this triangle into half, this small triangle A and this part will be same. This part and this part will be same. So effectively, the area of this triangle which we are looking at is basically half of the area of the rectangle which encloses it. Okay? And the area of this rectangle will be the base into height. So the area of the triangle will be half of that, which is half into base into height. Half into base into height. So if you have the value for the base of a triangle and the altitude drawn from the opposite point to that base, we will know the area of this triangle for any triangle. So if I draw it like this is the base, this is the altitude. If I know the height and the base value, I can find the area of the triangle as half into base into height. If I know this value, let us say this value, I can consider any side as the base. It is immaterial which side I consider as the base. Only thing is, I should know the altitude. The altitude should be the perpendicular drawn to this side from the other vertex. So if I take this as the base, this should be the altitude. This is one method of finding area of a triangle. Another method is the Heron's formula, wherein if you know the values of all the three sides of a triangle, let us say this is 5, this is 6 and this is 7, you don't know the altitude, you can use the Heron's formula to find the area of this triangle. The Heron's formula says area will be S into S minus A into S minus B into S minus C, the square root of the entire thing, where A, B and C are the values of individual sides and S is something called the semi-perimeter. Which is nothing but the sum of the sides divided by 2. So in this case, the area will be, what is S? First of all, find that. 6 plus 5, 11 plus 7, 18 by 2. So S will be 6 plus 5 plus 7 divided by 2, which is 9. So it will be 9 into 9 minus 6, 9 minus 7, 9 minus 5, square root of that. So it will be 9 multiplied by 3 multiplied by 2 multiplied by 4, square root of that. 27, 54 into 4, square root of that. So if you know the three sides of a triangle, you will be able to find the area of this triangle using the Heron's formula. Now when you do problems from triangle, you should be quite familiar with the common lines that are drawn on a triangle. Let's say you have a triangle ABC. The line joining one vertex to the midpoint of the other side is called the median. This is the median. A triangle will have three medians, and the medians will meet at a point called the centroid of the triangle. Another important line that comes in a triangle is the altitude. or the height, that is the vertical line from each of the vertices to the opposite side. This angle will be 90 degree. This is the altitude. The meeting point of the altitude is called the orthocentre. Another important line in a triangle is the bisector of the angle. If I draw an angular bisector here, this is the angular bisector. The meeting point, we'll have three angular bisectors. If I draw an angular bisector to angle A and angle C, they will go through a point, a common point. That common point is called the incentre of this triangle. One more important line. If you draw perpendicular bisectors, altitude is a perpendicular, but it need not bisect the other side. But if I draw a perpendicular bisector, what do you mean by perpendicular bisector? It should be perpendicular and it should bisect. Bisect means it should divide into two equal parts. So if I draw a perpendicular bisector to each of the three sides, this is the perpendicular bisector. There will be three perpendicular bisectors. The meeting point of the perpendicular bisector is called the circumcentre. It is called the circumcentre. Okay. The circumcentre will be, we'll use the circumcentre to draw a circle around this triangle. We'll use the incentre to draw a circle within this triangle and so on. Now, before we go on to a few problems, let us look at a few more properties of two important triangles, the equilateral triangle and the right angle triangle. Look at this triangle. Here, one angle is 90 degrees. So that is why it is called a right angle triangle. Let us say this side is 6, this side is 8. One important property of a right triangle is that it follows the Pythagoras theorem, which says hypotenuse square, the side opposite to the right angle is called the hypotenuse. Square of the hypotenuse will be equal to sum of the squares of the base and the altitude. Hypotenuse square will be base square plus altitude square. So in this triangle, the base is 6, altitude is 8, so hypotenuse square will be 6 square plus 8 square. That means hypotenuse will be the square root of 6 square added to 8 square. This will be 10. So if you know the base and altitude of a right triangle, you can find the hypotenuse. In the case of a right triangle, the area will be half into base into altitude, which in this case happens to be the side of this triangle itself. So it will be 6 half into 6 into 8. Now let us look at the equilateral triangle. The peculiarity of an equilateral triangle is that all the three sides of an equilateral triangle are equal. All sides are equal, and subsequently all angles are also equal. If I take this triangle as ABC, all sides are equal, all angles are equal. Sum of these three angles should be 180. So each angle will be equal to 180 divided by 3, 60 degrees. So in an equilateral triangle, the internal angles are all 60 degrees. The area of an equilateral triangle can be found out using the same formula, area equal to half into base into height. in an equilateral triangle, we can see that this altitude will go through the center of BC. This side, if you calculate using Pythagoras theorem, you will find, if I say this side is A, one side is small a, then I can say that the altitude will be root 3 by 2a, and subsequently I will find that the area will be root 3 by 4a square. This is the area of an equilateral triangle. Now that we know some basic aspects of triangle, let us do a couple of problems. There is a triangle ABC. I am drawing the altitude of this from all the three vertices. Altitude means the angle should be 90 degrees over here. This is 90, this is 90. The altitude passes through this point, let me call it P. If this angle CPB is given as 100 degrees, CPB is 100 degrees, can you tell me what the angle CAB will be? That is the question. Given that CPB is 100 degrees, what is angle A? Now here, we use the various properties of this triangle. First of all, when you look at this line, the altitude from C, this angle is 100. So you can say that this angle should be total 180 for the line minus 100, which is 80 degrees. Okay, that is 80 degrees because this is 100, total is 180. Now if you look at this triangle, let me mark this point as Q. If you consider the triangle PQB, can you tell me this angle? In a triangle, the sum of the three angles should be 180. This is the CQ is the altitude, that means this angle is 90. We already know that this angle is 80, so 90 plus 80 makes it 170. So this angle should be 10 degrees. Now once you know this angle, consider the triangle BRA. I am marking this point as R. BRA, that is a right angle at R. This is 90 degrees. We know this angle 90 plus 10, 100. So the remaining should come in this angle A. So you find that this angle will be 180 minus the sum of 90 and 10. So this will be 80 degrees. Okay. This is how you solve some of these triangle problems. We look at one more triangle based problem before we end this discussion. There is a triangle A, B, C. I am drawing the median AD from point A to the other side. Can you tell me the ratio of areas? Of triangle this, let me say area 1 and 2. Can you tell me the ratio of areas 1 and 2? Look at the figure. What I said is AD is the median. This is the median. What do you mean by median? Median is the line that goes through the midpoint of the other side. Okay. So CD and DB are equal. As we know, both these triangles ACD and ADB will have the same altitude. The altitude of both the triangles are the same. Base also is same. So area of triangle 1 and triangle 2, both of them will have the same area. The ratio will be 1:1. So in this discussion we touched upon some important aspects of triangle, and we saw two simple problems on triangle. The more you do problems on triangle, you will be familiar with these properties and problems. Thank you.